Thank you for inviting me to your e-Meetup, to your AIDS e-Meetup. And yeah, thanks for joining this little talk about designing a serverless application with domain-driven design. So $2.840 trillion US, that is the estimated amount that poor software quality was costing the US economy in 2018, according to a research study from the Consortium for IT Software Quality. So poor software quality is tremendously expensive. There are not really very easy indicators, or there are not really simple measures for bad or software quality. Instead, there are some metrics that could be used as indicators for poor software quality. So an increased defect trend over time, low test coverage, psychomatic complexity, or a significant depth of inheritance, high degree of class coupling could be some potential indicators for subpar code. Also, a high amount of effort to understand a piece of code or badly engineered software resulting from immature practices or undisciplined practices can also be some potential indicators for poor software quality. Also, the lack of domain knowledge and communication and coordination issues in teams are potential indicators for poor software quality. When talking of software quality, I would like to talk about domain-driven design, a development philosophy defined by Eric Evans. And domain-driven design comes with the core statement: to build better software, its software design supposed to be aligned to the business domain, to the business needs and the business strategy. But domain-driven design comes with a lot of new terms and that requires some time to grasp and to understand. For example, when I started with domain-driven design, for me, entering the domain-driven design field was very overwhelming. And I would like to visualize the journey to domain-driven design today by using Wardley maps. So Wardley Maps has been created by Simon Wardley, the researcher from the UK. And a Wardley map is the representation of a landscape a business is operating in, and it visualizes the evolution of a value chain. So what is a value chain? So behind every user need, there is a value chain. It starts off with the first question: who are your users? So who are coming to you and searching for help? And what are the user needs? So what kind of problems do they have that they would like to get solved by you? And what are the components and activities that fulfill the user needs, either directly or indirectly by facilitating other components and activities in that value chain? And how do these these components and activities depend on each other, and what kind of position do they have in the value chain? So at the top, we have those components and activities that are visible to your users, so where your users are touching the system directly. And at the bottom, it gets less visible to the users themselves. And after we have defined the value chain, including the dependencies and the position, we take this value chain and plot this value chain along an evolution axis, going from left to right, going from genesis with brand new things that had never happened before, and never existed before, then custom build, and product and rental, for example, open source software and off-the-shelf products, and commodity and utility. And the movement of a component from left to right is determined by its stage of evolution. Wardley Maps comes with some patterns and principles, and in the interest of time, I'm just highlighting a few of those. So one pattern is that the map is never static, but very, very dynamic. So everything evolves from left to right through the forces of demand and supply competition. And while the components are evolving through the evolution stages, their characteristics change. So, their characteristic change from the uncharted, the undefined, uncertain, unpredictable, constantly changing market, to the through all the evolution stages, to the industrialized evolution stage, to the mature, known, widespread, commonly understood market. And also, one of the principles is that you should use appropriate methods per evolution stage. And so the evolution stages help you to identify what components to build in-house. So these are the components and activities that are residing in the Genesis and custom build evolution stage. And where to use or buy off-the-shelf products. These are the components that are residing in the product and rental evolution stage. And where to outsource to utility supplier. These are the components in the commodity and utility evolution stage. And another principle is that it's very important to know your users and focus on the user needs, because the user needs are the subject area for what we build software. So they are the why, the purpose of our business domain. Before we develop a solution that solves our user needs, we need to understand the problem domain first. And since, as I mentioned in the beginning, the lack of domain knowledge could result in poor software quality. And that's where domain-driven design comes in, where the collaboration between the domain experts and development team is an essential part. And in order to gain domain knowledge, which is described in terms of the shared language, the ubiquitous language. And domain-driven design is composed of, or consisting of, the strategic and tactical design patterns and principles and practices. And when we enter the field of strategic and tactical design, I would like to combine it with a Wortley map and use the y-axis to plot their position in the value chain. So going from top from strategic design, going further down to tactical design. So we start at the problem space of the strategic design, and that's where we analyze the business domain and discover the subdomains. I come to that one later. And then we switch to next step, should go further down and switch to the solution space of the strategic design. That's where we do high-level design decisions and decompose our problem domain into modular components, the bounded context, and mapping their interaction patterns between the bounded context, the context maps. And then switching further down to the tactical design, that supports to make low-level design decisions and architecting and implementation that fits the problem domain as close as possible, and that provides building blocks to implement the domain model. When distilling the problem domain, we are partitioning the problem domain into smaller subdomain. That's a set of interrelated use cases and business processes. And by partitioning our problem domain into smaller subdomains, we are reducing the complexities. And not all subdomains are equal to the business. So some are more valuable to the business domain than others. So we have different kinds of subdomains. We have the core subdomains, the supporting subdomains, and the generic subdomains. The core subdomains, that's the essential subdomain. That's the essential part of our problem domain, and that's providing competitive advantage. That's the subdomain we should strategically invest in most. And these are supposed to be quite hard to copy and imitate, so they tend to be very complex and they tend to change very often. So the core subdomain, that's the one that we should strategically invest in most and innovate on, and that's the one that we should build in-house. So those goes into the Genesis and custom build evolution stage of Wortley map. The supporting subdomain supports the core subdomain, but they do not provide any competitive advantage. They tend to be quite simple and they do not change often. And if possible, we should look out for buying or use off-the-shelf products or use open source software. If that's not possible, and we need to custom build this supporting subdomain, we should not, we should not spend invest heavily in those components of the supporting subdomain. And the generic subdomain is a subdomain that a lot of companies have, and they, for example, payment or authentication. And they are not core, and they do not provide competitive advantage, but many businesses cannot work without them. they're generally complex, but already solved by someone else. And they tend to change not very often. So for those components in the generic subdomain, we should look out for buying or using off-the-shelf products, or outsource to use open source software, outsource to utility suppliers. When we are going further down at the y-axis, we are now switching to the solution space of strategic design, of domain-driven design. And that's where we decompose our system into modular components, the bounded context, which forms the boundary around domain models. And so within each subdomain, we can create a domain model that representing the domain logic and the business rules, reflecting that are relevant to the specific area of our business. And the domain model itself comes in different shapes. So, for example, that in the beginning, we are forming it comes with as an analysis model, for example, an UML diagram or product sketches that are the result of the collaboration between the domain experts and the development teams. And later on, it could result into a code model in the technical design area. I come to that one later. And what is really important to highlight here is that the domain model itself, it's not containing any technical concern, but instead it's reflect the business logic itself, and is described in the terms of the shared language, the ubiquitous language. And a model cannot exist without a boundary, and that's where we come to the bounded context. The bounded context can provide different types of boundaries, and it forms a consistency boundary around the domain model to protect its integrity. It also forms a linguistic and semantic boundary so that the languages term of a domain model is consistent only in that boundary itself. It also serves as this ownership boundary, so that means that one bounded context can be owned or can be implemented, evolved, and maintained by one team only. However, one team can own several bounded contexts. And it could also serve as a physical boundary and can be implemented as a separate solution. And so not every bounded context needs to be apply the same architectural pattern. It could also architectural patterns can be different per bounded context, and also the business logic implementation patterns that I come to later on as well. And bounded contexts are optimal or very good candidates for microservices. So let's create an example. Let's jump into now the practical part, and let's create an example of a SaaS conference solution that helps conference organizers to manage to create a CFP, a call for paper, and manage their event. So what kind of users do we have? So we have the conference organizers on the one side and the speakers on the other side. And what kind of user needs do they have? So the organizer would like to create a call for paper, a CFP, and manage the event that the speaker then has the possibility to submit a sessions proposal to. The organizer would like to evaluate the submitted sessions and build and publish a schedule of the accepted sessions, communicate with the speakers, and sign up and sign in into the conference solutions as well. As a next step, we are going to decompose our problem domain, which is shaped by our user needs, and into smaller subdomains, and to discover the core subdomain, because that's the core subdomain is the one that we would like to strategically invest in most. After analyzing the business domain and partitioning it into subdomains and identifying, discovering the core subdomain, we are now had some knowledge crunching sessions, for example, with the domain experts, and we're gaining domain knowledge and derived our first domain models such as session event evaluation that represent the business logic and the business rules of that specific area. And they are also described in the terms of the ubiquitous language and do not contain any technical concerns. But we noticed that some of the domain models are related by other domain models as well. For example, CFP, session, and speaker are reflected in other domain models as well. And but for example, a session proposal has different attributes and rules that are applicable than, for example, a session that we are scheduling for the agenda. So when we create the schedule or the agenda, the session itself has to have the attributes of a time slot and room, and we have to double check. We have the business rule that we are not double booking a session itself. But the attributes of room and time slot and double checking or double booking a session, this is not relevant when, for example, the speaker would like to submit a session proposal, or that are not relevant, these attributes and rules are not relevant when we are evaluating a session. So to keep the consistency and integrity of our domain models, we need to adjust our ubiquitous language. So now we are talking about submitted sessions, scheduled sessions, and evaluated sessions. And this is a strong indicator that we need to place a boundary around our models, so that the bounded context to keep the meaning of our models consistent and clear. And so these bounded contexts forms a linguistic and semantic boundary and protects the integrity of our models. And as mentioned earlier, these bounded context also serves as an ownership boundary, so that that can be owned by one team only, but one team on the other side can also own several bounded contexts. And this enables autonomous teams working at their own bounded context at their own pace with minimal impact across other teams. Bounded contexts also serve as a physical boundary, as I mentioned earlier, so they can be implemented as a separate solution and can be deployed as a separate artifact. The bounded context as a physical boundary also enables to have separate data stores that are not accessible by other bounded contexts, for example, and the source code of each bounded context can be organized in its own Git repository with their own CI/CD pipeline. And each bounded context can have different architecture patterns applied. And that's where we enter the field of the tactical design. So for example, one bounded context can go with a layered architecture where we split our source code into layers such as presentation, business logic, and persistence layer. And or as a hexagonal architecture, a specific form of layered architecture that I will address a little bit in a minute, or as CQRS, command query responsibility segregation, where we split our business logic into different models for reading information and for updating information. The hexagonal architecture is also called ports and adapters, and it's aiming for separation of concerns and creating loosely coupled software components that are easily connected to their software environment by using ports and adapters, and that makes those components easily exchangeable and also facilitate testing. The hexagonal architecture categorizes your software components into an outer and an inner part, and where ports and adapters are used to connect from the outside to the inner part and from the inner part to the outside. I make an example later on. So another part of the tactical design solution space could be also that we can implement the business logic with different implementation patterns. For example, we can use the domain models that provides some building blocks I will describe in the next slide. And the domain model is coping very well with very complex business logic, and they are very suitable for example, for our core domain. Or the active record that represents a row in a database and encapsulate the database access and adds a logic to that data. and so that carries both the database access, the data, and the business logic itself. Or transaction script, in the active record itself, that's very usable, for example, for the supporting subdomain, where we can deal with quite simple but business logic, that operates on a complex data structure, for example. Or we can use transaction script as a business logic implementation pattern that organizes your business logic by procedures, where each procedure handles a request from the presentation. And it's very well suited for small applications that does not implement any complex logic. So to go to the building blocks of the domain models, that we have several. I only would like to list a few of them. So we have, for example, the value object. I will make an example later on so that to make it a little clearer. So a value object can be identified by its values, and they are immutable. So when we change the value of a value object, we are replacing this with a new object instance. Or the aggregate itself, that is composed, of the entity that is identified by a unique ID, and its state can change over time. The aggregate itself is composed of entities and value objects and represent a hierarchy of objects and draws a clear consistency boundary and can act as a transactional boundary. The repository is providing mechanisms to load entities and aggregates from an underlying storage mechanism, and also loading and saving aggregates and entities to that storage mechanism. And also domain events, which represent a specific message representing a specific event that has happened in the business domain. And the application service itself, that's the one that orchestrates and manages use cases and transaction and does not contain any business logic. So to give you a little example, so for example, when we are modeling the event domain model, it could consist of an event aggregate that is composed of the event entity, and the event entity is identified by a unique event ID and consists of additional value objects for name, event status, description, and period. And the event entity itself could be used as an aggregate root. The aggregate root is designated as the public interface of the aggregate itself. So now we have learned about domain-driven design and Wortley maps and how to combine them. But so how can we now build a serverless application? And I would like to give you a brief overview of serverless. So with serverless, with the function as a service context, we have now a server to manage and to maintain and provision, and we get our infrastructure fully managed by the cloud provider themselves. And the serverless spectrum, we are using not containers anymore, like when we go from the Kubernetes orchestration platform, but instead we are now having the function as a unit of work, a fine-grained short-lived function, which is triggered by a variety of different events, such as HTTP requests or database events, file uploads, and so on. And the functions are automatically scaled scaled dynamically by usage. So we only pay for execution. So when we don't use our function, it gets idle and shuts down and costs nothing. So, so serverless on AWS, for example, comes with core building blocks that you can wire together with and build your application, a serverless application itself. So let's create an example using the combination of hexagonal architecture and domain-driven design. So let's say we would like to build a backend API with serverless on AWS and for our bounded context of event management. And we want to provide, we would start first from the outer part to the inner part, and we would like to provide REST endpoints that are exposed by an AWS API gateway that triggers Lambda functions. The implementation of the AWS Lambda functions are done in the event controller, and that's the adapter for the incoming requests, and passes those incoming requests then to the event application service to go to the inner part. So this is example source code written in TypeScript that is implementing several Lambda functions. So I would like to focus on the Lambda function of publishing an event. And so what the event controller does is implementing the function AWS function interface and takes the request, in this case an API gateway event, parses it and checks whether it's syntactically correct. For example, if it carries the event ID as its path parameter. If it's syntactically correct, it's then passing this to the application service, event application service, which is the gateway to the inner part of our hexagonal architecture. And that's where we go in the next step. So the event application service itself is it's executed by the event controller, and it's orchestrating use cases and managing transaction, for example. In this case, it is the gateway to our domain model, to our which is consisting of an event aggregate, and it also executes the event repository. So, and the source code of this could look like this, so that we are loading the event aggregate from the underlying repository, the underlying storage mechanism, using the event repository, executing the events, the aggregates publish method, and then making a state change and saves the state change then to the underlying storage mechanism. And the aggregate itself is then, so that means that we are now going to the domain model itself, which is then the aggregate that I was talking about earlier, and the source code of this one looks like this. So it's implementing the business rules and the invariants, and it checks whether the event has been, for example, closed before, then we can't publish it, and checks an invariant. So it only consists of domain logic, but no technical concerns at all. So it does not take care of itself to store itself into the database. That's the application service taking care of it. So, and then it goes further down to the event repository, which is just an interface, which is then providing some storage mechanism methods, which is implemented by the DynamoDB event repository that stores the event aggregate into a DynamoDB table. So the combination of domain-driven design and hexagonal architecture enables you to build adaptive and evolvable services where you can exchange the outside and outer part of your system without affecting the inner part of your business logic. So your business logic remains the same no matter what kind of infrastructure you have at the outside. But since domain-driven design focuses on complex business logic, it's not applicable everywhere. So it's very suited for very complex business logics and scenarios, and that's, for example, it's very well suited for your core subdomain. And so we should not implement or using domain-driven design, for example, for your supporting or your generic subdomain. So domain-driven design itself helps you to gain domain knowledge with the collaboration between your domain experts and development teams, and to describe this domain knowledge with terms of the ubiquitous language. And it also helps you to build better software by aligning a software domain to your business domain and business needs and business strategy. And also discovering your core subdomain, because that's the one that you should strategically invest in the most. And it helps you to decompose your system into modular components, the bounded context, which also helps you to organize and structure your serverless application itself. But since domain-driven design focuses on, copes very well with complex business logic, it should not be applied everywhere. It should be applied very well suited for your core subdomain, and that's why you should focused on most for using domain-driven design. So I posted some references that you can also look up to. And for that one, okay, thank you so much for listening. And I'm just looking at the timer. I'm running out of time. So, but we have time for questions, by the way.
Yeah. So you can raise your hand or you can just unmute yourself and start asking questions. We want to hear your voices. Okay. Anyone? Danny, you all the time have questions.
I loved it, but honestly, you asked me, I loved it. It was interesting, but I'm really not experienced with domain-driven design, and sometimes it's just overwhelming. It was a new approach. I loved it. I link it to things that I saw before, but because the topic is too far from where I am right now, I have to disappoint you with no questions, but just saying that I enjoyed it.
Thank you.
Can I ask the question?
Yes.
So basically, my question is simple: how to approach this domain-driven design with legacy code, whereas everything is kind of I saw the head of Jimmy Bogart. so how do you approach this the domain-driven design when you have really legacy code, big ball of mud?
Yeah. So what I like about domain-driven design is that it's consisting on the consisting of strategic design and tactical design. So it does not mean that you have to implement it using the tactical design. It's also very helpful when you start with strategic design to gain domain knowledge. So collaborating with your domain experts first. So and then derive the domain model from your legacy system. For example, doing in terms of like gaining domain knowledge, in terms of like doing event storming sessions together, like trying to look out for what is what is happening in your domain, for example, to understand, to get together the big picture, what has happening in your legacy system, and then also identify the bounded context, potential bounded context of your legacy system, and identify, for example, a module that you can use to apply domain-driven design with it. So if it's kind of like that you don't, so there's not necessary a necessity if you don't have a problem with your current legacy system. It's also not, I would say, you don't have to transition to domain-driven design just to apply domain-driven design. It's more like understanding your domain. That's the thing that I was, for example, experiencing, which was very helpful to start with strategic design first instead of just jumping directly into tactical design and decompose just apply aggregates, entities, value objects, and so on, without having previously understood your domain first. So it's iterative. It depends also on the context, like what you would like to solve by it. It's if you would, for example, do you want to introduce microservices, or do you would like to just to make it more modular? There are different approaches that you can follow. Does it answer your question, or do you have an...
Okay, it's okay. Actually, thanks for the answer. But do you have some documentation about the strategic design?
Yeah, in the references there are some links to that one about in the several books that I have from Eric Evans to Vaughan Vernon to Nick Tune, Vladek Kononov. He gave also a very brief description of what is domain-driven design to give them, because I guess to start the journey, to start into domain-driven design, for me it was really overwhelming. So the book that Eric Evans has written, I guess it took me a while to go through the entire book, and a lot of repetitions, and it was iterative. For me, I needed an iterative approach. But I have put some references to my slides, and then I will publish my slides later on.
Okay, thank you, and thanks for the presentation.
Thank you.
Okay, Bill, I see you raising your hand.
I'm being very fancy. This might be in your resources, but any tips on ubiquitous language or any good recommendations for what I always have that problem with domain-driven design, trying to get people to figure out what the ubiquitous language should be. Any tips there?
It's part of the books, yes. Yeah, ubiquitous language is, sometimes there are also different approaches, like someone says, okay, it's only the language that the domain expert talk, but it's I would say that's the shared language between the domain experts and the development team, so that it's the common, that reflects the common understanding, but both of them are understanding behind the domain, and not like in terms of like describing it in technical terms, in terms of like, oh, this is a database item, for example, or something that is really technical, that's a strong indicator that is not reflecting the shared language, because it's not reflecting the domain specifics. And so what my approach is that during the collaboration with the domain experts, because they are usually not, in my experience, they are not the one that are technical, they're talking in technical terms, they talk about the domain. And if they are able to design the domain model together with you, then you both have the same understanding what the domain model is. And I guess it comes out, you find probably terms that are not a little bit different than the one that, for example, the sales department uses all the time. But for example, you can negotiate on a language that both understand the development team and the domain experts themselves.
That makes sense.
Yeah. Does it answer your question?
Yes, thank you.
Okay, great.
Vytautas, you could ask this by yourself. He wrote in the chat, what person to look for in the team, company, business, senior developer when defining context? And how many projects you have to practice DDD until you start to understand what you are doing?
I guess it's an iterative process. So it's not like, okay, when I have done it 3 times, then I'm an expert of it. It's like, so there's always this phrase, like every domain is, every model is wrong. I guess it applies even to machine learning. And so I guess it's still an abstraction of your problem domain. And I guess it's just try it out. You don't have to be an expert, and that's the good thing about it. You don't have to have technical experience to for example, to do event storming, because everyone can be involved. So when I started with it, it was like I was really hesitant, like, hey, can I moderate? So I started, for example, with event storming session where you have this lightweight modeling process with stickers where you identify domain events along a user journey, how to identify what happened along chronological timeline. And when I started with it, I guess the good thing is there are no rules in terms of, okay, if you do it this way, then this is wrong, and if you you only can do it that way, then it's right. There is no wrong or right. It's as long as you are gaining a big picture or your common understanding of the domain, then it's very beneficial. And so, for example, you can do it in a chaotic way, for example, with event storming, that everyone is posting stickers on the wall, and or you can also moderate it in a structured conversation. So both are reasonable approaches, and it depends on the preference. And that also applies to domain-driven design, I would say, that and finding the bounded context is sometimes not really easy. So as I'm trying to highlight, like when I have domain models that are related to other domain models, and but they have different attributes and different rules applies, and we have to edit to make it consistent and clear, that could be a good candidate to identify that there must be a boundary to keep that domain model clear inside its bounded context. For example, what I have tried to highlight with session, like submitted session, evaluated session, and scheduled session.